We will do a brief demo to show how the tool works. When you click on the Start button, it will take you to the next page. In this page, you see the hydrologic module, BMP selection module, BMP sizing module, and the cost module. We'll briefly go through each module. The first module you see is the hydrologic module. User can use our hydrologic module, or they may use outputs from another hydrologic model they have. If they want to use their own model to input the runoff data, they can select user input option. If they want to use our hydrologic module, they need to select calculated option. User can select event-based or continuous simulation, and in both cases they can use green-amped and curve number method. When you click OK, it will take you to the next page. Let us select green-amped option. Here you have input button for various inputs. For precipitation, user may choose the daily or sub-hourly data. For example, if users select a sub-hourly data, they can input the precipitation time series data in the spreadsheets. When you click back to GUI, it will take you back to the user interface. The user needs to select evapotranspiration options as well. For the soil parameter, the tool allows up to 10 land segments where you can choose different soil types and percentage of area under each soil type. But for the purpose of demonstration, I will just go with one land use. When you choose a soil type, the soil parameter will be populated automatically. When you click OK, it will take you to the output page, where you can see time series of runoff hydrograph and precipitation and infiltration rate. The next module is the BMP selection module. The BMP selection module selects a BMP type based on inflow water quality, target water quality, BMP removal efficiency, and other criteria such as cost. The water quality data is obtained from the stormwater quality database. If the user has their own water quality data, they have the option to use their own data. In the stormwater quality database, the water quality changes with NCDC climate region, land use, and level of concentration. Just for illustration, I want to select the southeast for a region, industrial for land use, and median concentration for the level of concentration. If you click on Show Water Quality Parameters, you can view water quality data. You need to click OK to accept the data. The next input is removal efficiency. We are using the BMP International database to get removal efficiencies for different BMP type. We have user preference options, which has lists of BMP. The users can include or exclude BMPs from the selection process. Also, in the user weighting input page, they can input weights for the different criteria ranging from 1 to 5. After completing the inputs, users can run the BMP selection by clicking the Run BMP Selection button. The optimal BMP will be selected using an optimization procedure. For instance, here a wet pond has been selected. The next module is BMP sizing module. For the purpose of sizing, we categorize the BMPs into 3 different groups: green roof system, infiltration-based BMPs such as bioretention and sand filter, and storage-based BMPs such as detention and retention pond. Let us start with the green roof system. In the green roof system, the goal is to determine how much area has to be under the green roof to achieve a specific percent flow reduction. The area of the watershed, percent imperviousness, and runoff hydrograph comes from the hydrologic module. Let us say if I want to run the tool for 10% flow reduction, the tool will calculate the surface area that has to be under green roof. Okay, so if I increase the percent flow reduction from 10 to 20%, the area required will increase. Yes. Now you may also view the hydrographs from the graphical output. The blue line hydrograph is without green roof, and the red line is a hydrograph with green roof. The next group of BMPs are infiltration-based BMPs. Here again we have some input including site features that are obtained from the hydrologic module. We have BMP features including BMP surface area, soil properties for various layers, and the water quality parameters. User can input the area of the BMP and the tool will calculate the percent flow captured, drawdown time, and the percent pollutant removal. The user can play with the BMP surface areas. For example, for 120 square feet and 2 acre of watershed area, the percent flow captured is 17%. And you can see the percent pollutant removal and drawdown time here. If I increase the surface area of the BMP to 250 square feet, the percent flow captured will increase to 33%, and also the percent pollutant removal is improved. The tool also shows the graphical outputs of inflow and outflow hydrograph. We are also tracking the water in the ponding layer. The tool also generates design curves for the flow and pollutant, which is a graph of the percent flow captured versus sizing factor. And sizing factor is the area of the BMP over the impervious area. In a similar way, the tool generates a pollutant design curve, which is a graph of the percent pollutant removal versus a sizing factor for various pollutants. For each type of pollutant, we are using the first order decay, and if the user wants to modify the decay rate, they can change these parameters. For TSS, users can change sediment grain size. This may take time. Okay, I guess we are close to complete the run. And the final result will be percent pollutant removal for each specific pollutant versus the sizing factor. The third group of BMPs is storage-based BMPs. In a storage-based BMPs like detention pond and retention pond, we have again some input parameters that comes from the hydrologic module. Here we increase our watershed area to 50 acres because the ponds usually are dealing with the bigger area. The user input here is a percent peak flow reduction, and the output from the tool is the geometry of the pond, geometry of the outlet structures, and the percent pollutant removal. I'm running the tool for 50% peak flow reduction and other input parameters. And the tool is searching for optimal geometries of pond and outlet structures through an optimization process, which may take some time. We developed optimization approach to find the minimum volume of the pond, because if we minimize the volume of the pond, we can minimize the cost while we are satisfying other constraints such as drawdown time and orifice size. And again, like infiltration-based BMPs, we are using the first order decay and sediment grain size as inputs. So the sizing is complete. Now we can see pond geometry, volume and surface area of the pond, and also outlet structure geometry for the orifices and weirs and percent pollutant removal. We have also graphical outputs so the user can view inflow and outflow hydrographs and the peak flow reduction. The last module is BMP cost module. The cost estimate is based on the size of the BMP determined using the BMP sizing module. Here you see the last BMP we designed. The size information from sizing module will come here automatically to the cost module. Here the information for the dry pond, including the surface area and the volume, are displayed automatically. If the user wants to just use the cost modules for a BMP with noun size, they can click on the other BMP type button and select the BMP type and input the area and volume here to calculate the cost. We are using ENR cost data for 20 cities in the United States. They can change the different cities. Now we are just using the Denver, Colorado, and if the city is not listed, they can use the Tyson polygon and use the data from the closest city. If users want to run the cost analysis for these input parameters, the total cost will be calculated. The total cost includes capital costs, operation maintenance costs, and other related costs. We also have graphical outputs to view the capital cost, rehabilitation costs, operation maintenance costs, present value, future value. The tool will also show the distribution of the costs, including capital costs, operation maintenance costs, and other related costs over the lifetime of the project. This is the end of the demo. Thank you.